Hello, chemist. Jolly here again. This is question 2 on the multi-spectra workout problems, and this is the answers, me working them out so that you can follow along. All right, so this is question number 2. We know it's a proton NMR because it's going from 0 to 9 and they're splitting. So the first thing I'm going to do is I'm going to find my number of peaks. 1, 2, 3, 4, and 5. So I know I have 5 peaks. I'm going to add up my hydrogen, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, it's odd, so I know there has to be a nitrogen or a halogen. So if you go back to your units of unsaturation, remember hydrogens always come in evens. The only time you wouldn't is for nitrogen or if one's been replaced with a halogen. So I know something important, and that automatically pulls my eyes right here. 3.5, that is the perfect location to be connected to somebody electronegative. So let's try and get our splitting and our location. All right, so this has the peaks on both sides that are pretty much symmetrical. So this looks like a triplet to me. This looks like a triplet. All right, this one looks like a triplet. I'm not sure what's going on with those two, but see, there's only one peak on the side, so I'm going to hazard a guess and say it's a singlet. Now, we could be wrong. We're not going to fall in love with any of this data, but that's what it looks like. And then, of course, a multiplet and a multiplet. And then this one is about 3.6. This one is about 2.2, about 1.9, and a 1.6. And so, what do I think this is? This is the electronegative region. So I'm going to go up here and I'm going to say A, B, C, D, and E. All right, so I have a triplet that's integrating for 2 hydrogens. So I have a triplet that integrates for 2 hydrogens, and it is at 3.6. So what do I think that is? In order to get a triplet, I'm going to need 2 neighbors. So CH2 is what I'm looking at, and in order to get a triplet, I would need 2 neighbors, and in order to shift all the way to 3.6, I need to be next to somebody electronegative. And I'm using the generic Z because it doesn't always have to be a halogen, could be an oxygen. So that just means somebody electronegative. All right, what about B? B is a triplet also, and it is also integrating for 2 hydrogens, and it is at about 2.2. All right, so again, I have a CH2 because that's my integration, and I know it needs to be next to a CH2 to get the triplet, but then I need to be close to something that pulls it in the 2.2 world, and the 2.2 world, this 2 to 3 world, belongs to anybody connected to an sp2, and that includes going on with a carbonyl. So I don't have any proof of a carbonyl, but it could be right here. So I'm just going to put a little sp2, okay, because that's what most often occurs between 2 and 3. All right, now a singlet integrating for 1 at 1.9. Singlets are always interesting, but 1 proton integrating is very interesting because more likely than not, it's going to be a heteroatom, an NH, an OH, or it could be a CH, completely isolated from everybody. Okay? Probably not likely, though. Probably not likely. So it's probably an OH or an NH, and they pretty much show up wherever they want. And then the 2 multiplets aren't helping me much. A multiplet for 2 hydrogens at, we'll just say 1.8 so that it doesn't interfere with the one above. And then I have another multiplet for 2 hydrogens, and that is around 1.6. All right, nothing is jumping right now, and I have other spectra. So rather than take the time to go further than that, I'm going to go look at the other spectra and see what I can glean before I spend too much time there. All right, I know this is a carbon 13, because it's going from 0 to 200. And there is 1, 2, 3, 4, 5, and 6 peaks. So I know there are 6 unique types of carbons. There is no splitting, and beware the shadow peak. Okay, that's a shadow peak. But what I can do is, this is the sp3 carbon world. Doesn't tell me much, but these are shifted, which means it's connected to somebody interesting. All right, so something has happened. So A and B has been shifted. If we look on our sheets, what occurs between 60 and 100? Now, right now, there's a lot of things that occur between 60 and 100. If this was the only spectra I had, I would really try and dig more into it. But I have other spectra, so it's given me pretty much what it can. So I'm going to go down to the IR. Oh, this IR is screaming at me. All right, remember the hydrogen world? Whoa, whoa, look at me. I am an sp hybridized carbon. I'm an alkyne. If you say there's an alkyne, there better be a carbon-carbon triple bond, which there is. And then this nice little oven mitt is your sp3s. And then we would go about 19. All right, that's a bad line. And then to 15. There's nothing going on in there. This looks like I have an alkyne. Huh. That was very, very nice. And then let's go down here, and I'm going to go all the way to the right. And, ooh, those 3 kind of look like, you know, they're pretty small. They look like backgrounds. So the one that I could go for is maybe that one. And that's molecular weight 115. That is awfully, awfully small. And if you'll notice, I gave you which molecular weight it was. So because I told you we wouldn't put that one, we would actually find the 116 peak. And that would be right. Wow, look how tiny that thing is. There's your molecular ion peak. And that's pretty much all I could label here. Molecular weight is 116 AMU. And what can I glean from this? Well, 116. I did not have any indication of anything crazy from my other structures. So let's go up here. An alkyne wouldn't really help me in the mass spec. The carbon 13 didn't really help me in my mass spec. But notice I specifically said 9 hydrogens. I either have to have a nitrogen or a halogen. Let's go back. My peak is so small that I can't get my M+2 peak. Okay, it's too small. That's normally where I would figure out whether it's a chlorine or a bromine, but I can't figure it out. So I'm just going to take a guess. It's either a chlorine or a bromine, and it's only 116, and bromines weigh 79 by themselves, so I'm going to start with the smaller one. So I'm going to say 1 chlorine. So 116 minus 35 is going to give us 81. And how many carbons could I get? Well, let's do 6 carbons, and that's minus 72. And 81 minus 72 is 9 hydrogens, which I already know from the proton NMR. So it looks like my formula is C6H9Cl. All right, let's check it. 2 times 6 plus 2 is 12, 13. I should have 14 total maximum hydrogens. I only have, now remember, the halogen counts as 1. So 9 plus 1 is 10, so that leaves me 4 divided by 2. That gives me 2 units of unsaturation. So I could have 2 pies, I could have 2 rings, or I could have 1 pi and 1 ring, which we know it's this one because we have the indication of alkyne. All right, so let's go back up top here and get a structure. We now know there is an alkyne in there. Oh, where do alkyne hydrogens show up? Guess what? Right here. Now we don't use them very often, so notice I put a little sp2. Remember, we don't fall in love with anything. We knew it was shifting, it was doing something unique, and it just didn't turn out to be that one. So from future ones, I found out that it was this from those other spectra. All right, so I took care of that one, and I know that there is a CH2 connected at the end. Okay, I know this has to be at the end. And so this takes care of 1, 2 carbons. And let's add some CH2, CH2, CH2. So let me see, 1, 2, 3, 4, 5, 6. All right, let's make sure there's 9 hydrogens. 2, 4, 6, 8, 9. All right, that looks like my structure. I would predict a singlet that integrates for 1, and in the alkyne world, okay, which would be about that, 2 region. All right, this would be a 1, 2, 3. This would be a triplet that integrates for 2. It is right next to, okay, it is right next to some kind of group. In this case, it's an sp, not an sp2, but that matches as well. So this should be somewhere between 2 and 3. This one is sandwiched in between, so it's 1, 2, 3, 4, 5. This should be a pentet or a multiplet that integrates for 2, and it's going to show up somewhere between 1 and 2. This one is going to be a multiplet that integrates for 2, somewhere between 1 and 2. This one is going to be a 1, 2, 3. That is going to be a triplet that integrates for 2, and it's going to be between 3 and 4. That matches exactly what I had, so I'm going to put in what letter goes to what carbon and which hydrogens. All right, so the furthest down field is this one. All right, C had to be that one. All right, now who's my 2 hydrogens that was a triplet that was shifted the most? I'm actually going to say that being next to the chlorine is probably a little bit more important than being next to the alkyne. I could be wrong, but I'm going to say, so what letter is that? That is B. And then D, the closer to the alkyne, and then that leaves poor E stuck right in the center. All right, let's go to our carbon 13. One, 2, 3, 4, 5, 6. Notice I didn't write the hydrogens in this one except the ending. Your choice. On the proton NMR, you should write the hydrogens, but on the carbon 13, your choice. All right, so who shifted down the furthest? All right, now we get to take a note here. Do I think that the 2 alkynes are the furthest? Or do I think one of those carbon next to the chlorine is the furthest? Now remember, I told you never go for height as the first choice, but this one is so short, it usually means it has the least hydrogens, and so I'm actually going to say this one's A. Okay? I'm actually going to say that one's A. And then B and C, there's going to be a toss-up. Alkynes usually show up in the same world, so I'm going to choose that one as B. I'll choose this one as C. And then who is closest to C would be D. Who is next close would be E and F. Now I could be wrong. Okay, B and C could swap. Okay, B and C could swap back and forth. But that is a pretty good guess. Okay, that's a pretty good guess. And I want to make sure that that's actually what I put on the workout problem for you, on the answer key. Yep. Okay. All right. Again, B and C. Could be wrong, but that's my educated guess. All right. And then everything I've done matches what I have on that IR, and it matches my formula, and it matches my units of unsaturation. And so there is question 2 done. All right. Until next time, jolly out.